Okay, here we want to be able to find the horizontal and vertical asymptotes of the curve. Y is equal to x squared plus 5 over 9x squared minus 26x minus 3. So when we want to find the vertical asymptotes, in order to do that, we have to set our denominator equal to 0. So we have 9x squared minus 26x minus 3, and we're going to set that equal to 0 and then factor. So what we can do is we can use the AC method to be able to factor this. So just as a review, we have AC, which is equal to 9 times negative 3, which gives you negative 27. And then we have the value of AC, which is negative 27, and the middle number is negative 26. So what two numbers can you multiply to get negative 27? And when you add them together, it's going to give you negative 26. Well, it's going to be 1 and negative 27. So now we're going to factor this to be 9x squared plus 1x minus 27x minus 3, and that's equal to 0. And now we're going to factor by grouping. So we're going to group the first two terms. So we're going to factor out an x, and what's left is 9x plus 1. And then over here, we should also get 9x plus 1. And so what can we factor out? From here, we can factor out a negative 3. So therefore, we end up getting 9x plus 1 times x minus 3, which is equal to 0. Now let's set both of them equal to 0. So we have 9x plus 1, which is equal to 0. Or x minus 3 is equal to 0. So solving for x over here, we get negative 1/9 and positive 3. So therefore, these are our vertical asymptotes, where x is equal to negative 1/9 and 3. So the smaller value is negative 1/9, and the larger value is x is equal to 3. Okay, now we need to find the horizontal asymptote. So how do we find the horizontal asymptote? Well, we need to find the limit of this function. So what we want to do is we want to find the limit as x approaches infinity of the function x squared plus 5 divided by 9x squared minus 26x minus 3. So how do we find this limit? Well, what we need to do is we need to divide both the numerator and denominator by the highest power of x that occurs in the denominator, which is x squared. So what that means is we're going to multiply the numerator and denominator, or divide the numerator and denominator by 1 over x squared. And the same thing here, we're going to divide this by 1 over x squared. So in our second step, we have the limit as x approaches infinity. And so we have x squared over x squared plus 5 over x squared divided by 9x squared over x squared minus 26x over x squared minus 3 over x squared. Now let's go ahead and simplify. So we have the limit as x is approaching infinity. So x squared divided by x squared is 1 plus 5 over x squared divided by 9x squared divided by x squared is 9 minus 26 over x minus 3 over x squared. So now what we want to do is now we're going to evaluate this limit as x is approaching infinity. Well, 1 is a constant, so we have 1 plus, well, if we write 5 over infinity, 5 over infinity is going to equal 0. So we have 1 plus 0 in the numerator. Okay, divided by, we take the limit as x approaches infinity of the constant 9, so that is 9 minus, similarly that we did in the numerator, 26 divided by infinity is going to give us 0. Minus 3 over infinity is also going to give us 0. So now when we calculate this limit, we get 1 over 9. So therefore, the horizontal asymptote is y, which is equal to 1/9. So therefore, y is equal to 1/9 is the horizontal asymptote.